How to avoid memory leaks with JavaScript promise-based code. Imagine your web application running smoothly without slowing down over time. That's what avoiding memory leaks is all about. Today, we're going to look at how to keep your JavaScript promises from sneaking into your memory and causing trouble. Memory leaks happen when promises stay in memory longer than needed. This often occurs when promises are chained or created recursively without proper cleanup. For example, if you keep creating promises in a loop without a clear exit, they pile up. Over time, this can slow down or crash your app. One key tip is to avoid infinite or unbounded promise chains. If you have a recursive function that returns a promise, make sure it has a clear stopping point. Using async and await inside loops with break conditions makes this easier. It keeps your code cleaner and prevents promises from lingering forever. Next, always releases references to promises and their callbacks once they are no longer needed. If you store a promise in a variable, set that variable to null after you're done with it. This allows the garbage collector to free up memory. Holding onto promise references longer than necessary is a common cause of leaks. Replacing nested promise chains with async and await syntax is another smart move. It simplifies your code and reduces the chance of creating complex reference chains. When you write code with async and await, it looks more like regular synchronous code, making it easier to manage and less prone to leaks. Implementing timeouts on promises is also important. Sometimes promises never resolve because of network issues or errors. Adding a timeout ensures that promises are rejected after a certain period, preventing them from hanging in memory forever. You can do this by creating a race between your promise and a timeout promise. Avoid wrapping synchronous code in promises unless necessary. Wrapping non-asynchronous code creates extra promise objects that can stay in memory longer than needed. Use promises only when you're dealing with actual asynchronous operations like fetching data or waiting for timers. Closures can also keep large objects in memory if promises capture variables unnecessarily. Be mindful of what your promises are capturing. If you don't need certain data inside a promise, avoid capturing it in the closure. This reduces the risk of holding onto large objects longer than needed. Finally, use debugging tools and memory profilers available in browsers or Node.js. These tools help you spot lingering promise objects or unresolved chains. Regularly profiling your app helps catch leaks early before they cause bigger issues. By following these practices, you can write promise-based code that is both efficient and leak-free. Mastering async and await, managing promise lifetimes, and keeping your code clean will make your web applications faster and more reliable over time.